Hello, my name is Gabriella Korf, and the title of my study is Octopus Oliveri Abundance and Moon Illumination. Do they rise and fall together? Some background information. Octopus are keystone species, which means that the health of the species is directly correlated to the health of the environment. If the species is thriving, so is the environment. But if the species is declining, so is the health of the environment. Most octopus species are nocturnal, which means that they hunt by the illumination from the moon. This led me to wonder, how well can octopus actually see? As it turns out, octopus can see really well. They have camera eyes just like humans. They're able to see in the dark as well as in the light, under the water as well as above. They also can see color, contrary to popular belief. The purpose of this study is to fill a gap in the information of Octopus oliveri. Some species of octopus have been highly studied, while others have hardly been studied at all. Octopus oliveri have hardly been studied at all. Only 2 papers have been published based on this species of octopus. I hope to share my knowledge that I've gained from this past semester to help inspire future research papers based on this species. That photo on the left is the first time that I held an octopus. I made a prediction that moon illumination and tidal amplitude would have separate impacts on the abundance of Octopus oliveri. From these predictions, I hypothesized 2 hypotheses. First, does Octopus oliveri abundance increase with moon illumination? Second, does Octopus oliveri abundance increase as tidal amplitude decreases? To test these hypotheses, I headed out to Kewalo Basin Harbor in Oahu, Hawaii. I did 12 octopus surveys over the span of 3 months, resulting in 7 individual octopus sightings. When I arrived at the study site, between the hours of 7 p.m. and 8 p.m., I first noted the moon illumination and the tide amplitude for that night. I then headed down into the water. Facing the rock wall, I walked along the dotted line as shown in the map below for approximately 40 minutes, searching every nook and cranny to see octopus. I then noted every octopus that was seen. As with all studies, there were some trial and error with this one. The first issue that I ran into was I struggled identifying the octopus. The photo on the bottom left-hand corner shows 2 different Octopus oliveri. They're sitting on the rocks and they blend in very well. They're very small also. On the right-hand side is a photo that I took while I was doing my surveys. It's a photo of an Octopus oliveri in the hole of a lava rock. It was very challenging to find, but I'm glad that I did. The other issue that I ran into was not having enough data. That's what we'll get into on the next slide. Data analysis and results. I did 2 different data analysis tests. A multiple linear regression, which looked at the relationship between the independent variables, moon illumination and tide amplitude, compared to the dependent variable of Octopus oliveri sightings. I got a p-value of 0.237 for the multiple linear regression. I then did a chi-squared, which looks at the expected data based on the amount of effort that was put in 12 octopus surveys versus the actual data that I received, which was 7 octopus sightings. I got a p-value of 0.813 for this. As I kept alpha at 0.05 for both of these studies, it showed that 0 statistical significance was found. I then did an electivity/preference test. This takes what was the ecological variable that was available to the octopus and puts it against the actual ecological variable that the octopus chose. It then gives a value that puts it on a sliding scale from 1, meaning high preference, to -0, meaning no preference at all. High illumination got an electivity value of 0.89, and low illumination got an electivity value of 1. Both of these values typically mean high preference, but because the variables are complete opposites, it equals 0 preference or significance. High tidal amplitude got -0.69, and low tidal amplitude got 1. Both of these are on opposite ends of the sliding scale, meaning that there was significance. Octopus preferred low tidal amplitude over high tidal amplitude. If I were to recreate this test, I would first get more data. I would then redo the data analysis test to see if there actually was no relationship between the variables, or there just wasn't enough data to find one. If I were to do a future study, I would probably look at prey and/or predators of Octopus oliveri. When I was out searching, there were many individual species that I saw as I was looking for Octopus oliveri. Some of them include different types of urchins, various species of crabs, sea cucumbers, limpets, and even gobies. Any of these could be prey and or predators of Octopus oliveri. In conclusion, the first hypothesis, which asked, does Octopus oliveri abundance increase with moon illumination, was not supported by any of the analysis tests that I performed. The second hypothesis that asked, does Octopus oliveri abundance decrease as tidal amplitude increases, was not supported by the quantitative data, but was supported by the qualitative data, which was the electivity test, showing that there was a preference for low tidal amplitude. Future studies should be conducted to support or disprove the findings of this one, as there are no past papers that look at these variables for this specific species of octopus. I would like to thank Dr. Heirenbach for advising me throughout this project, Dr. Ayeki for getting me started, supporting me, and going on surveys with me, and lastly, Holden Brown for going on surveys with me and for letting me practice my speech on it. Thank you very much.